This video consists of the answers of the VIIT exam conducted by Satkam. Our case study is electric scooter company case study. So our group members are Sahil Lavande, Uday Kuthe, Shivam Shinde, and Mir Kolpute. So the first question is that the company wants to do analysis of the app and what it needs to improve. Mind map the 10 features you would want in an app for electric scooter and explain which are the top 5 features which would be most useful and why. So the top 10 app features would be real-time battery status and low charge alerts, Google Map navigation, document storage and access, redesign UI UX, instant notifications, ride analysis speed, distance, energy usage, remote unlock, lock, smart charging, scheduling, peak off optimization, offline mode such as basic functions without internet, and voice command support. And the top most useful features are real-time battery alerts, Google Map integration, redesigned UI UX, document storage, and smart charging notification. And second is what are some of the design considerations you would have for designing the storage features, and what all will you need to consider for security of the documents while designing the architecture. So the design considerations for document storage features would be first that is UX user experience, intuitive upload flow that is drag and drop and camera scan, then folder and category organization with search functionality. Then third is seamless sync between app and dashboard for real-time updates and often access to critical documents, example insurance. The storage architecture includes scalable cloud storage with CDN for fast access, local caching on devices for offline use, and tiered storage limits that is free versus premium users. Security considerations would be encryption, access control, compliance and audits, data integrity, and infrastructure.
So third question is potential reason for an two of the issue, which is customer have complaints and about and write the test scenario you would use to test and ensure they have been fixed. The first issue is like charging time increase and sudden depletion. Potential reason, first point is potential reason. Battery degradation due to poor charge cycle management, and flawed software algorithm for charge estimation. Test scenarios, degradation test, charge discharge of the battery 500 plus times, measuring time to full and capacity retention. Low charge warning test, draining battery to 10% and verify the app and trigger alert to 20%, 50% and 10%. Issue 2. Delay and outdated app notification. A potential reason, insufficient cloud sync architecture, OS level background and throttling of an app process. A test scenario, a real-time sync test, lock unlock scooter and major notification latency less than 2 seconds. Throttling test, enable battery saving mode on Android or iOS and verify notifications still arriving promptly. So fourth question is use the inside about sorry outside the technique to realizing a product to make market and list of the 5 things you would do inside your planning and re-release realize the new app to the market and outside the planning for realizing the new app. Inside out planning internal focus. The first is critical bug from the previous app and version like notification delay. Second is optimize cloud infrastructure for real-time data sync and scalability. Third is conduct rigorous beta testing with employee and select users. Fourth is implement security audits for document storage and API endpoints. Fifth is stress test app performance under peak user load, outside in plan, outside in planning, like market customer focus. Uh, First is launch early access program for loyal customer to gather feedback. Second, run targeted ads highlighting new features like Google Maps, faster charging. Third is partner with influencer for demo video and reviews. Fourth is monitor social media app store to real-time user sentimental post launch. Fourth, offer. Fifth, offer intent incentive, example like free charging accessories for early adopters.
So fifth question is based on the list of top 10 features you have selected. Do a relative priority exercise to mark them from P1 and P2, like priority 1 and priority 2, and then from 1 to 10, and explain why you have decided those priorities. So, like features, our feature first feature is real-time battery alerts. Its priority one and rank is one. Reasoning directly solves complaint, sudden charge depletion, and prevent user frustration. Second is redesign UI UX. Rank two addresses the clumsy UI complaint which impacts user retention and app rating. Google Map integration rank its rank is 3. Competitive defender aligns with user demand for navigation. Fourth is instant notification, rank 4. Fix delays, alerts, critical complaint, and ensure real-time reliability. Fifth is document storage. Its rank is 5. A unique selling point for legal and insurance use. Aligns with brand goals. Sixth is smart charging schedule. Its priority in P2. Rank 6. Optimizes charging but secondary to fixing existing battery issues. Seventh, analytics. Rank 7. Useful for power users but not urgent for mass adoption. Remote lock and unlock. Rank 8. Security perk, low cost but not critical for launch. Ninth, offline mode. Its rank is 9. Niche use case can be added post launch. 10th, voice commands. Rank 10. Nice to have for future updates. So sixth question is the company is collecting the data in the cloud already, but have had performance issues to collect the data and update the app. What can be the reasons for that, and what will need to be improved for the data integration from the vehicle to cloud, and to send the data post analysis to the app. So potential reasons for performance issues like high latency APIs, poorly optimized REST endpoints, or excessive payload size. Second is inefficient data serialization, like uncompressed JSON and XML instead of binary formats. Example protobuf. Third is database bottlenecks, lack of indexing or slow queries on time series data. Fourth point is network congestion, scooters in low connectivity area causing retries and timeouts. Fifth point is no edge computing, raw data sent directly to the cloud without pre-processing. Next point is improvement for data integration. So in that first is protocol optimization. Use MQTT for lightweight, real-time, and vehicle-to-cloud communication. Edge processing, filtering and aggregating data locally on the scooter before transmission. Third point is data compression. Adapt RO protobuf to reduce payload size by 60 to 70%. Fourth point is caching layer. Deploy Redis for frequent app data request. Example battery status. Fifth is async pipelines, which which explains stream data via Kafka for parallel processing and real-time dashboards.
So then seventh is the company would like the app to have intelligence and provide recommendations to the driver. what kind of data should the app collect from the vehicle, and what kind of recommendations can be done. Is there a possibility to use ML and or AI for this analysis? And if so, what can be the use cases? So, data collection from vehicle, battery metrics, charge cycles, voltage, temperature, degradation patterns, then ride dynamics, speed, acceleration, braking force, motor load. Then third one is environmental factors, terrain type, via accelerometer, GPS elevation, ambient temperature. Then fourth one is usage patterns, daily mileage, frequent routes, charging habits. Fifth one is component health, motor temperature, tire pressure, and brake wear. Recommendations to drivers. First one is optimal charging. Suggest charging times based on grid demand, off-peak hours, and battery health. Then second one is route optimization. Recommend energy efficient routes using terrain or traffic data. Then third one is maintenance alerts. Warn about brake pad wear or tire pressure drops. Then fourth one is efficiency tips. Advise smoother acceleration to extend battery life. And the last is battery preservation. Notify users to avoid 0% discharge or prolonged 100% charges. Then ML or AI use cases. So first is predictive maintenance. How train models on historical failure data. For example, motor overheating patterns. Then outcome is predict component failures. For example, brakes 2 weeks in advance. Then second is battery health forecasting. How use LSTM networks to model degradation from charge cycles. And outcome is estimate remaining battery lifespan and suggest replacements. Then third one is personalized route planning. How reinforcement learning to optimize routes for energy efficiency plus user preferences. And outcome is reduce energy use by 15 to 20% on hilly routes. Then fourth one is anomaly detection. How autoencoders to flag abnormal motor vibrations or battery drain. Outcome early warning for potential safety risk, for example overhealing. Then why ML or AI transforms raw data into the actionable insights. For example, predictive battery issues before they occur. Then enables hyper personalization. For example, adapting recommendations to individual riding styles. Then the last but not least is the use the product solutioning concepts and create a mind map for the new version of the vehicle explaining the goals, features, UX changes and UI changes, if any you want to target in the scope. So first one is core goals, business, achieve 10% profit or unit from 10% loss, 50% sales boost in 6 months, market rank 2 in 1 year. Operational zero critical issues post-launch, cost control, no price hike. Then second one is key features, hardware, lightweight frame, aluminum or composite materials, fast charging battery, less than 4 hours with degradation, resistant BMS, multi-terrain suspension, gravel or cement optimization. Then software is redesigned app with real-time sync, Google Maps and document storage, AI-driven recommendations, route optimization and battery health. Then dashboard is 7 touchscreen tablet with sunlight readable display, navigation integration, turn by turn directions. Then third one is UX changes, app or dashboard synergy. Single sign on for app plus dashboard access. Drag and drop docs from app to dashboard. Ride experiences, terrain adoption alerts. For example, gravel mode activated. Haptic feedback for low battery warnings. Then accessibility, voice guided navigation for hands free use. Then offline mode for basic functions. For example, unlock clocks access. Then UI changes, app redesign, simplified navigation, bottom menu, home, maps, docs, and profiles. Color coded battery status, green greater than 30%, orange 10 to 30%, and red less than 10%. Live charging progress with time estimates. Then dashboard of UI, split screen view, maps plus battery or performance metrics. Then customizable widgets, example frequent docks or favorite routes. Then dark or light mode auto switch based on ambient light. Thank you.